Hello guys, good afternoon. You are welcome to my YouTube channel, The Explicit Tutorials. As you all know, I'm Mr. Joseph or Mr. Explicit. And please, as you watch this video, do subscribe so that when I upload new videos, you would be notified by YouTube. Alright, so in today's class, we are going to be discussing Chem 102, a topic, metals and their properties. Metals and their properties. Before I jump into this topic, I want to say congratulations on the just concluded first semester examination. All right, I want to say happy resumption. Of course, this is the first video on the first semester, second semester courses. All right, so the first semester courses were very easy. All right, were very easy. Chem 101, Physics 101, MTH 101, Bio 101. They were easy peasy. All right, but looking at second semester courses, they are complex and bulky. All right, so you need much time. You need to start making preparations for you to have good grade in these courses. And don't forget that ASU strike is on, it's still ongoing. All right, so please, I want to give you a piece of advice. Do not be carried away by the ASU strike, because when lecturers start setting your questions, ASU strike may not be considered. It therefore means that you have officially resumed second semester, right? So it is high time you began reading your books, study the courses that you have, because they are quite bulky and they are complex. They are much more difficult than first semester courses, all right? So please do well to start following up on my YouTube channel and also do your personal studies. So let's jump into what we have for today. All right, so today's topic is metals and their properties. In other words, metals and their general properties. All right, so we are going to be looking at the properties exhibited by metals on a general note. Don't forget that metals are solids at room temperature, or you see that metals are solid at normal temperature, except mercury, which is liquid in room temperature. All right, so what are the properties of metal? Don't forget that metals, they have high melting and boiling points. All right, metals have high melting points and high boiling points. That is metals. Take for example sodium. You know sodium is Na. All right, it is Na because this Na was gotten from the Latin word, which is what? Natrum. The melting point of sodium is 800 degrees Celsius. All right, of course, don't forget that sodium is extracted using a process called the Down process. During this process, calcium chloride is added in order to reduce the melting point of sodium from 800 degrees Celsius to 600 degrees Celsius. So on a general note, metals have high melting point and boiling point. That's for number one. Number two, don't forget that metals, they are opaque. All right, they are what? Opaque. You don't say they are opaque. All right, they are opaque. Why do you say metals are opaque? They are opaque because you don't see through them. There is substances or objects you see through. You say they are what? Transparent. But objects you don't see through, you say they are what? Opaque. The human body is an opaque what? Body. All right. When we talk of rectilinear propagation of light, when light rays are incidented on an opaque object, shadows and forms as well as what? Eclipse. So opaque objects and objects you don't see through, while transparent objects is an object you can see through. All right. So that is metals, they are opaque generally. That is, you don't see through them. That is metals for you. Then number three, don't forget that metals are sonorous. All right, metals, they are what? Sonorous. Now sonorosity is the ability of a metal to make a bell-like sound when it is struck. All right, that sound, that bell-like sound that a metal makes when struck, you call it what? The sonorosity of what? That metal. So metals, they are sonorous because they make a bell-like sound when they are struck. Number 4 is that metals are lustrous. Alright, the lustrousness of a metal is the ability of that metal to what? Shine. Alright, the shiny appearance exhibited by metals is due to the presence of what? Luster. That is Lustre. Alright, the luster is responsible for the shining appearance of what? Metals. We therefore see that metals are lustrous because they have shining appearance. Do not forget that. Number 5 rather, metals are lustrous, yes. Metals are malleable. Alright, the malleability of a metal is the ability of that metal to be hammered into sheets. Alright, the ability of a metal to be hammered into sheets is called the malleability of that word metal. So when a metal is malleable, it means that it can be hammered into what? Sheets. Alright, now number 6, metals are ductile. Alright, a ductile metal, or when a metal is said to be ductile, it means that metals or such metal can be drawn into thin wire. But take note that there's a metal that is malleable, it is lustrous, but it cannot be what? Drawn into wire. And that metal is called what? Tin. Alright, it's called what? Tin. And don't forget that tin, denoted as Sn, alright, strontium, alright, it is a lustrous, is a silvery white, is a silvery white metal, alright, and it has a melting point of 200 degrees Celsius and a boiling point of 2770 degrees Celsius. The melting point of tin is 230 degrees Celsius, but its boiling point is 2270 degrees Celsius. That is for that, okay? It is not ductile, alright? It cannot be drawn into thin wire, alright? Number 7, don't forget that all metals are electropositive. Positive. Alright, that is, they are electron donors, alright? They give out electrons. Alright, metals can be monovalent, that is one valence electron, divalent, two valence electron, trivalent, three valence electron, or polyvalent. All the group 1 elements such as lithium, sodium, potassium, rubidium, all of these, and cesium, all of these are what? Monovalent. Alright, what about elements in group 2? You have the calcium, you have magnesium, you have beryllium, boron, okay, barium. All of these, they are what? Divalent, because they have 2 valence electron in the outermost shell. What about boron and aluminium? Alright, these we call them trivalent elements, because they have 3 valence electrons in the outermost shell. Alright, what about carbon? Carbon has a valency of that is a valency of 2, but a maximum of what? 4. So it belongs to group 4. Alright, it's a group 4 element. But elements that are polyvalent, we have what's it called now? Polyvalent or polyatomic rather. Let's say polyatomic, that is what? Sulfur. Sulfur is what? Polyatomic. Do not forget that. So they are what? Electropositive. And please take note that metals also have high tensile strength. They have high tensile strength, they have high density, except a few. For example, sodium has a density of 0.97 gram per cm what cube. Alright, this is the density of sodium. Sodium is a soft silvery white metal. Because of its low density, it is found floating on water, right? So please do not forget that. Of course, metals, they are cations. Alright, they are cations. You know, when we talk of ion, we have 2 types of ions. We have the cations and we have what? The anions. These ones, they are what? Positively charged. And these ones, they are what? Negatively charged entities. Do not forget all this. So these are the properties of metals. They have high melting point and boiling point. They are opaque, they are sonorous, they are lustrous, they are malleable, they are ductile, they are electropositive, they have high tensile strength, they have high density. Alright, do not forget that. Now before I call it a day, today, let me drop something. Don't forget that metals can be, we have the highly reactive metals, and we have the moderately reactive metals, and we have the least reactive metals. Now when we talk of electrochemical series, alright, it is the arrangement of elements based on their reactivity, alright, and the readiness to displace less reactive ones. It therefore connotes or denotes that elements that are highly reactive are placed on top of the electrochemical series. So elements found in the top part of the electrochemical series are highly reactive. The ones at the middle are moderately reactive, and the ones at the bottom are least reactive. Do not forget that elements that are highly reactive, such as potassium, calcium, alright, they are extracted through electrolysis or electrolytic method. But elements that are moderately reactive are extracted by chemical reduction. Alright, elements that are moderately reactive are extracted by chemical reduction. Then elements that are least reactive can be extracted by burning them. Alright, don't forget I said that calcium or potassium, that's a potassium now, sodium is extracted through a process called what? Down process. Alright, down process. And what is the ore of sodium? We call it what? Rock stone. The ore of sodium is called rock stone, and this rock stone is called sodium chloride. Alright, sodium chloride. But sodium is found in combined states. You can find sodium in some compounds. Alright, sodium can be extracted from some compounds. We have please, some students take this for this. Alright, now this one that does not have water of crystallization is called soda ash, but this one that has water of crystallization is called washing soda. This one is white crystal, but this one is what? Colorless. So this soda ash, and this is what? Washing soda. We also have NaHCO3. What do I call this? Sodium triisocarbonate 4, trivially called baking soda. Alright, so this is what? Baking soda. Baking soda. Do not forget that. Alright, don't forget that too. What about sodium hydroxide, also called caustic soda? Alright, what about KOH, called soda ash? Alright, why is calcium hydroxide called caustic soda? It is called caustic soda because it is injurious to the skin. It is very, very corrosive when it hasn't been diluted. Alright, concentrated caustic soda is highly corrosive. Do you understand? So please take note of that. What about NaNO3? We call this saltpeter. Please, it is not Peter that denied Jesus. We are not talking of the Peter that denied Jesus, okay? We are talking of Petre, saltpeter, or saltpetre, or saltpetre, but it's pronounced as saltpeter. Alright? So these are the compounds that sodium can be extracted from. Do not forget that I said that sodium has a melting point of 800 degrees Celsius, but when calcium chloride is added, the melting point is reduced from 800 degrees Celsius to 600 degrees Celsius. Do not forget what we have done. If you did enjoy this video, subscribe so that when I upload new content, you would be notified by YouTube. And please comment, like, and share. All right, do not forget that. So in our next class, we are going to be looking at every element, or that we are going to be looking at every group. That is the every element in each group. Group 1, Group 2, Group 3, and the transition metals, Group 7 and Group 8 or Group 0 element. Thanks for watching and do have a wonderful day.